supposed to be using a graphing calculator, we had, really low scale res, graphs. So that's part of the reason. But in any event, these are the rules that you need to remember. Rational function px over qx has a hole at x equals a if p at a and q at a is equal to 0, 0. So that's what we talked about. So that's this, right? This occurs when p and q contain a common factor of x minus a. For example, has a common factor of x minus 2, the numerator and the denominator. This results in a hole in the graph at x equals 2. Okay, any questions about the first one? I think that's pretty clear, right? If we have 0 over 0, we get a hole. A rational function f at x equals p over q has vertical asymptote at x equals a if we have a value over 0. For example, this has a vertical asymptote at x equals 2. When x is 2 here, this is 3 over 0. So this is that exact scenario where we would have 3 over 0. It's a vertical asymptote. So we have a number over 0. We have a vertical asymptote. Any questions about the second point? Okay. A rational function f at x equals p over q has a horizontal asymptote only when the degree of p is less than or equal to the degree of q. Alright, so here's where we got into a little bit of confusion. When the degree of the denominator, when the degree of the numerator p is less or equal to q, we have a horizontal asymptote where the coefficients divide. Okay, so here's the scenario where they're equal. Hold on, Angelica, I might answer your question here. So here's the scenario where they're equal. Okay, so degree so the degree is equal. It's on the numerator and the denominator. Oh, sorry, x here. My bad. The degree is equal, so we have a horizontal asymptote where the coefficients divide. Okay? So that's one example. The other example is if the denominator has a greater degree, and I'm going to put it over here. When the denominator has a greater degree. So this is our other example. Okay, denominator has a greater degree. We still have a horizontal asymptote, but it's at y equals 0. Don't have to do any division, and it doesn't matter what the coefficients are. Yes.
Is it only a horizontal asymptote if it's just the x on top? Like, what if it was an equation with 2x? Like
No,
5?
no. If this was 3 and this was a 6, horizontal asymptote at y equals 0.
No, so I'm saying like the numerator has like, let's say it was like 2x plus 5. Would it still have a horizontal asymptote?
Something like this. Something like that. Still horizontal asymptote at y equals 0.
So for an example,
It only has to do with the degree of the highest exponent.
So if the is a negative difference.
If what?
If the numerator degree is smaller than the denominator degree, what's the horizontal asymptote 0?
Yes. Okay? When denominator has a greater degree, there's a horizontal asymptote. Okay? And the proof of that, again, unfortunately, I can't just put it into an equation and show you the proof. It's just running all these different polynomial functions into a graphing calculator and seeing that pattern emerge. Okay? Yeah.
But you had mentioned we we don't need to know when the degree is greater on top. We don't need to know that yet.
You need to know, it's right here, the last one. Okay, we're going to talk about that now. So we have an oblique, a slant asymptote, only when the degree of P is greater than Q by exactly 1. So for example, when we have this scenario, okay? And yes, you don't need to know the equation for the oblique yet, okay? We will learn it, yes.
We would just state that it's an oblique asymptote.
Yes, right. You need to know, and remember, it's only when the numerator has a greater degree by 1 over the denominator. It's not an oblique asymptote. Something else. I don't know. Okay? Any other questions?